Let's go to 2A. An arithmetic sequence has a first term of 60 and a common difference negative 2.5. Given that the case term of the sequence is 0, find the value of k. Since this is arithmetic sequence, case term of the sequence is 0. U sub k equals U sub 1 plus k minus 1 times d equals 0. U sub 1 is 60 plus k minus 1 times negative 2.5 equals 0. I will use equation solver to solve this k by solver. We will go to y equals 60 plus x minus 1 times negative 2.5. Math solver 10 as an estimated value. Alpha, enter. Answer will be 25. By solver, k equals 25. For 2b, let S sub n denote the sum of the first n terms of the sequence. Find the maximum value of S sub n. We know S sub n equals, for arithmetic sequence, we will use n over 2. 2 U sub n plus n minus 1 times d equals n over 2. 2 times 60 plus n minus 1 times negative 2.5. Let's organize n over 2. 120 minus 2.5n plus 2.5. We will put this into the graphing calculator to figure out the maximum. Change n into x, x divided by 2. 120 minus 2.5x plus 2.5. Then go to graph. Change window. This x will be from 0 to 50. Scale is 5. For the minimum, let's do negative 100. Maximum 100. Scale is 10. Then go to graph. You could say the maximum will be between 0 to 50. And a maximum positive 100, it didn't work. So go back, change the window. Let's change maximum into 1000. Then scale, change into 100. Go graph again. So we could say this maximum value on the graph. Second trace, 4. So move the cursor to the left to get the left bound. Then move the cursor to the right to get the right bound. Enter, enter. X equals 24.5. Y is 750.3125. By graphing, maximum point is 24.5 or 750.3125. Since n is a natural number, we need to test 25 or 24 to get the maximum value for this S sub n. Go to Y1, we plug in 24, then enter 750, alpha trace, put 25, enter. Answer is the same, 750. So maximum is 750. Let's go to 3a. An infinite geometric series has a first term usable 1 equals a, and the second term usable 2 equals 1 over 4a squared minus 3a, a greater than 0. Find the common ratio in terms of a. We know the common ratio equals usable n over usable n minus 1. So we have 1 over 4a squared minus 3a over a. That equals 1 over 4a minus 3. For 3b, find the value of a for which the sum to infinity of the series exists. If the value of a for which the sum to infinity of the series exists, which means these are greater than -1, less than 1. So we will set up 1 over 4a minus 3 greater than -1, less than 1. Add 3 both sides, 1 over 4a less than 4. -1 plus 3 is greater than 2. Then multiply by 4 both sides, a less than 16, greater than 8. For 3c, find the value of a when s sub infinity equals 76. For s sub infinity equals 76, which means u sub 1 over 1 minus r equals 76. U sub 1 is a. 1 minus r will be 1 over 4a minus 3. Don't forget to put the parentheses equals 76. Since this question is a calculator based, we will use the equation solver. We have a over 1 minus 1 over 4a minus 3 minus 76 equals 0. By solver, a equals, we have alpha y equals x over 1 minus parentheses 1 divided by 4x minus 3 parentheses back, then minus 76. Math, upper arrow, go to solver. 10 as an estimated number, alpha, enter. A equals 15.2. So A equals 15.2.